Okay, today is January 12th, 2012, lesson 8.4. All right, we have this triangle here. We need to find an entire bridge, the truss of a bridge, all of the measurements added together. So, I have the first angle, which was 37. We quickly already figured out that because that's 90 degrees, 180, subtract 37, subtract 90, gave us our 53. So we discovered that the other angle is 53. Now I need to find this side of the triangle here. We'll call it an x again. I have the measurement of the hypotenuse. This is the adjacent side, so I'm going to be using cos ratio. So I take cos 37 equal to, the adjacent side is our x divided by 6.2. We bring 6.2 to the other side. Cos 37 is equal to x. Our x is equal to 37 cos times 6.2. That didn't work. 37 cos times 6.2. There you go. 4.95. 4.95. So 4.95, that's what we're calling it. Okay. So this is 4.95 meters. Let's use Pythagorean's just so we use several laws to solve this. We can use Pythagorean's theory. Oh, you know what? I already have the sign here, so we're going to use sign. Opposite side. We need to find this opposite side. Let's call it y. That means sine 37 again is equal to, the opposite is our y. Our hypotenuse is still 6.2. We bring 6.2 over. Times sine 37. 37 sine times 6.2. 3.7. Okay. 3.7 meters is our y. So we have this is 3.7 meters. Since this is an equilateral triangle, all three of these sides are the same. That means each side of this triangle is 3.7 meters. And someone already told us because it's equilateral, we know all of the angles have to be the same. Therefore, they're all 60 degrees. Now, I have the measurement of our final triangle, which is 3.7 that side, but I don't have enough information yet. How can I find out some more information about triangle DBE, Michael?
60 plus 53 minus 180.
Yeah, that's right. We know a straight line has a measurement of 180. So we take 180 and subtract the other two angles we had previously. So 180, subtract 53, subtract 60. Does anyone know what it's going to give us? 67 degrees. Okay. So, that means this angle down here is 67 degrees. Oh, maybe. Maybe that's what I did. So, now that we have our 67 degrees, this triangle here, I gotta solve some of the sides. What can I use to solve some of the other sides of this triangle? Some of our formulas from over here. Michael, Isaac?
You have to use the...
Okay, so somebody, Anderson, observed that this is an isosceles triangle. Therefore, this angle and this angle need to be the same measurement. So this is also 67 degrees. And now that we have both those measurements, we can solve for our third angle. Okay, we're going to take 180, subtract it by 67 times 2. We'll subtract by 2 67s. What do we get? 46 degrees. So our other angle is 46 degrees. Now, I do need to find the other sides. Does it matter which one I solve? It doesn't, because they're going to be the exact same. So I'm just going to solve for one of them. Now, can I use one of these trig ratios here to solve for it? It's not a right angle triangle. So what would I use? Yeah, I'd probably use sine law just because it's usually the easiest to work with. I have a full ratio for sine law. We have 3.7 and 46. So let's set up sine law. Let's make a little room here. So our sine law here. We knew that the angle was 46. So we're going to say sine A is sine 46. Divided by, that side of the triangle was what? 3.7. Now both sine B and sine C are going to be 67. So it really doesn't matter which one we go to solve for because they're going to give us the same answer. We'll drop C off and we're left with this ratio here. We're going to cross multiply, so I get B times sine 46 is equal to 3.7 times sine 67. And I need to get B by itself. So we're going to divide both sides of this equation by sine 46. It'll cancel these two out, and we're left with B is equal to 3.7 times sine 67 divided by sine 46. All right, so let's put this together. I'll solve the top part first. 67 sine times 3.7 gives us 3.4. And sine 46 gives us 0.719. We divide those two numbers. 3.4 divided by 0.719, 4.7. So B is equal to 4.7. So we go up, found quite a lot of information, 4.7, 4.7. Does anyone remember what the original question asked us? No? Question asked us what was the total length of all the beams. So now that we have all these measurements, what do I have to do with them all? Got to add them up. So let's put them together here. 4.95, 6.2, 3.7, 3.7, 3.7, 4.7, and 4.7. Nope, I've actually included them all. Both 4.7s are there. Oh, no, we're not solving this part of the question. That was just a diagram. We're just solving the highlighted part. That would have been a good point. We also would have had to solve this then, though, because that one doesn't repeat. So we add up all of these. 4.95. Did you get it? What is it, Anderson? 31.65 meters. So that's how much material they need to build this part of the truss. Okay, example number 2. Example 2, we have a three-dimensional shape. Three-dimensional shape. So, what that means is this green part of the triangle is across a river. Okay, the river is horizontal. The yellow triangle is a vertical triangle. That's why it's a right angle triangle. If you look at this as flat, it doesn't make any sense. You need to think of it, this brown part is a cliff. This is the top of the cliff where it goes flat again. There's a river at the bottom of the cliff. Okay. Now they want us to find the height of the cliff. That's our goal here, to find the distance between A and B. In order to do that, I need to find at least one side of that triangle. Since line CB is technically part of both of the triangles, we're going to solve for line CB using the green triangle. Okay. Now, according to this green triangle, which of the ratios, can I use any of the trig ratios to solve it? Is it a right angle triangle? There's no proof it is. It might possibly be one, but we don't know that for sure. Can we use our sine law to solve this? Anyone know? Right, now we can. There is a quick way we could. That's right, we can just find out what this other angle is and then use our sine law. So 62 and 50 is 112. No, isn't it 78? Let's add them up. 62, 50. It's 112. 180 subtract 112. Oh, is it? Yeah, you're right. 68. Genius. All right, so 68 degrees. So we definitely know that this is not a right angle triangle. We can now use our sine law to set this up. We have a complete ratio. We have an opposite side and an opposite angle. So we're going to bring our sine law in. We're going to solve with this. We'll call angle A 68. So sine 68 is equal to, divided by 160 is equal to, now which ratio am I looking for? What side of the triangle do I want right now? I want CB, okay, this side here. So I'm looking for the side opposite of 50. We're going to call 50 our B. So sine 50 divided by, and we're going to call this side B. Okay, so we're going to rename this side B here. Or, since the lettering is confusing, let's call it Y. Okay, so we don't get confused. Side Y. We're going to cross multiply. We're going to do everything in black from here on in. Now, I didn't complete sine C because it was irrelevant. We don't need to solve any parts of those sides of the triangle, so I didn't include it in the sine law. So, when I cross multiply 160 and Y, we get Y multiplied by sine 68 is equal to sine 50 multiplied by 160. Then I got to bring sine 68 to the other side of the equation. So I divide both sides by sine 68. We end up with Y is equal to, these two cancel out, sine 50 times 160 divided by sine 68. Now, many of you guys may be able to put this in the calculator in one shot. Mine's a bit tricky. Does anyone know what this equals? 132? Altogether, it should be 132 meters. If you guys want, I'll do it quickly. 50 sine times 160 divided by bracket 68 sine and bracket equals. Didn't work out so well on my calculators. Should be 132. You can do it without the brackets on yours? So our side that we called Y, so the distance of the river essentially, is 132 meters. Now that we have the measurement of 132 meters, this is a right angle triangle, which means I can use primary trig ratios to solve our x. I have this angle, I have the measure of the adjacent side, and I'm looking for the opposite side, so which ratio would I use? Adjacent and opposite, what would I use? Tangent, that's right. So we're going to use our tangent ratio. The angle was 33 degrees. We were looking for the opposite, which was x, so tan 33 is equal to x divided by, and our adjacent side was 132. 132 times tangent 33. 3310 times 132. Oh, I didn't put it in right. $85.7. So according to this, we can round it maybe to 86 meters. So we just discovered that the height of this cliff, because remember it's three-dimensional, is 86 meters tall. Okay, homework 427, numbers 1 to 4, 13 and 14.